Hello students, in this video let us learn about the angle between the radius vector and the tangent and also the angle between two curves. So let us consider an example. Show that in the equiangular spiral r is equal to a e raised to theta cot alpha, the tangent is inclined at a constant angle to the radius vector. So the curve given to us, it is r e raised to theta cot alpha. Now what we need to show is the tangent drawn to this curve is inclined at a constant angle to the radius vector. So let me draw a curve. There is a tangent drawn to this curve. Now this tangent, what you need to show is making a constant angle with the radius vector. Suppose OP is the radius vector, PT is your tangent drawn to the curve r equal to a e raised to theta cot alpha. Then we have to show that the angle between the radius vector and the tangent is constant. So let us denote it by phi. We need to show that phi is constant. Now for this curve, what we do is we'll take log on both sides. Take log on both sides of this curve so that we have log r is equal to log a into e raised to theta cot alpha. Now this can be written as log a plus log e raised to theta cot alpha using the property log AB is equal to log A plus log B. Now the second term is again in the form of log A raised to m, which can be written as m log A. Now using this property, we'll further write this as log A plus theta cot alpha into log E. Now, but we know that log E is 1. Hence, we obtain log R is equal to log A plus theta cot alpha. Log E is 1. Now, we'll differentiate this equation with respect to theta. Derivative of log R, it is 1 by R dr by d theta. Derivative of log A, it is constant term, so we get 0. Theta cot alpha we have, so cot alpha is a constant term. Derivative of theta with respect to theta is 1. We also know that 1 by r dr by d theta represents cot phi if phi is the angle between the radius vector and the tangent. So denoting 1 by r dr by d theta by cot phi, we have cot phi equal to cot alpha. Now this implies phi is equal to alpha, which is a constant. Hence, we have shown that phi is a constant angle. Now let us move on to the example of angle between two curves. So consider the example. Show that the angle of intersection of the curves r equal to a log theta and r equal to a upon log theta is tan inverse 2e divided by 1 minus e square. So let us consider one by one. Take the first curve r equal to a log theta. Take log on both sides again. Taking log on both sides of this curve, we have log r is equal to log of a log theta. So this can be written as log a plus log of log theta, applying the property log AB equal to log A plus log B. Now we'll go for differentiating this with respect to theta. Derivative of log r, it is 1 by r. Again, r is differentiated with respect to theta. Log A is constant, derivative is 0. plus derivative of log theta. It is 1 upon log theta into again the derivative of log theta. It is 1 upon theta. So what we have is cot phi is equal to 1 divided by theta log theta. Now since this is for one curve and yet we have another curve, so let us call this as cot phi 1 equal to. Now let us consider the second curve r is equal to a divided by log theta. So take again log on both sides. Taking log, we have log r is equal to log a by log theta. So it is log a minus log of log theta by applying the property of log a by b equal to log a minus log b. Now we'll go for differentiating with respect to theta. Derivative of log r, it is 1 by r dr by d theta. Log a is a constant term, derivative is 0 minus derivative of log theta. It is 1 upon log theta into the derivative of log theta, it is again 1 by theta. So we have this as cot phi 2 equal to, it is for the second curve, so we'll call it as cot phi 2 minus 1 divided by theta log theta. Now I can see that the RHS of both cot phi 1 and cot phi 2 are not in terms of trigonometric ratios. Hence, we cannot evaluate phi 1 and phi 2 from this. So we go for considering the formula for tan of phi 1 minus phi 2. So for that, let us write what is tan phi 1 by taking the reciprocal. Tan phi 1 is theta log theta, and for the second curve, tan phi 2 is minus theta log theta. Now, the angle between the curves, we know that it is given by angle between the curves. It is given by mod of phi 1 minus phi 2. But since we cannot find phi 1 and phi 2, we'll consider tan of phi 1 minus phi 2. Now we know the formula tan of a minus b, it is tan a minus tan b divided by 1 plus tan a into tan b. So let us substitute the values. Tan phi 1, it is theta log theta. Tan phi 2, it is minus theta log theta divided by, we have 1 plus theta log theta into minus theta log theta. So this can be simplified as theta log theta minus of minus, it is plus theta log theta, which is 2 times theta log theta divided by, we have 1 minus plus into minus, it is minus theta log theta, again we have theta log theta. So it is theta log theta whole square. Now the angle between the two curves must not be in terms of theta. So for that, we'll consider the two given curves and try to find the value of theta by eliminating r. So given equations or the given curves, are, one is r is equal to a log theta, let us call it as 1, and r is equal to a divided by log theta. So let us consider it as 2. So we have the two curves. Now what we do is substitute one in the other. So substitute equation 2 in equation 1. So that makes a divided by log theta is equal to a log theta. For this r, we are substituting the value of a log theta. So it becomes a log theta is equal to, we have a log theta, a upon log theta equal to a log theta. Now what does this imply? A cancels from both sides. 1 is equal to log theta whole square, or we can write that log theta is equal to 1. If log theta equal to 1, we have theta equal to e raised to 1, that is nothing but e. Now let us substitute them in this equation. Let us call this as 3. Now substituting the value of log theta and theta in equation 3. Substituting in equation 3. So tan phi1 minus phi2, it is 2 times theta, that is e, log theta, that is 1, divided by 1 minus theta means it is e, log theta means it is 1, its square. So it is 2 times e divided by 1 minus e square. Now this is tan of phi1 minus phi2. Hence, the angle between the two curves, angle between the two curves is equal to mod of phi1 minus phi2, which is given by taking this tan to the RHS, will get tan inverse 2e divided by 1 minus e square. So this is the angle between the two curves. Thank you for watching.